This project has been completed as a part of Texas Instruments India Analog Design Competition 2011. The component used in this project, which we have named as Environmental Vehicle, a mobile weather forecasting technique, are as shown. The dedicated printed circuit board, that is the PCB, showing all important analog chips and the sensor. The three sensors which we have used in the circuit are the temperature sensor TMP401, the barometric pressure sensor SPD100GD, and the humidity sensor BHS220M. The PCB also has the three other analog chips which we have used in our design. They are the switch, the power management chip, and the buffer. The other two sensors are shown to be interfaced with the PCB. The microcontroller which we have used is the Arduino Uno revision 3. The main inspiration which led to the development of this type of design was inhuman and inevitable death of thousands of people who died due to inavailability or delay in receiving correct weather information due to working of meteorological department. To inform common man, we decided to design a low-cost environmental vehicle. This vehicle will be a mobile weather forecasting vehicle which shall inform us about the surrounding weather condition interrupted. For this purpose, we are using the above described three sensors, as they are the parameters which they measure are the most important and determining factor when any changes in the weather is concerned. Many globally renowned car companies are researching to produce such vehicles. Therefore, we thought, why not come up with our own device? Firstly, let me explain the working of individual chips and sensor, and then demonstration of entire circuit working can be shown in the end. First of all, let us have a look at the PCB. The first thing which we are using is the switch. This is SN74CB3Q3306A. In case of sudden power cut, the switch inhibits the backward flow of current and hence saves the entire system from getting damaged. Also, the low on-state resistance of the selected switch gives less propagation delay. The switch output then goes to the power management chip. The voltage divider bias is used to get the exact desired output voltage from it. It is used to drive the sensor network and the buffer. Then we have used two buffer. The buffer is OPA832. The buffer chips eliminates the loading effect due to mismatch in impedance between sensor network and microcontroller, and also provide protection against sudden noise channel. Then we go to the temperature sensor. The temperature sensor used by us is a TMP401. The TMP401 is a remote temperature sensor monitor with a built-in local temperature sensor. The humidity sensor. The humidity sensor used by us purchased by us is an analog sensor. It gives output in terms of voltage, which has been calibrated to give the relative humidity of the place. Now comes the most important part of our design, the pressure sensor. The pressure sensor purchased by us is a digital sensor which gives output as in 16-bit hex code. Therefore, the working prototype is demonstrated here. This demonstration is of the weather condition of the lab in which we are working presently. So let me switch on the entire system. This switching on enables the LCD. This is showing weather forecasting. It is giving the temperature of the lab, which is fluctuating around 17 to 18 degrees centigrades. The pressure now is shown to be 14.21 psi. This barometric pressure gives its unit in terms of pounds per square inch. The humidity now is 2.2 volt, which corresponds to 55%. Actually, this is a humidity sensor which gives its outputs in analog term. Therefore, the prediction is that rainfall is possible within 5 to 6 hours. As we know, a number of weather forecast results can be shown, but this being a prototype, we can provide a few of them. The few weather conditions are: decreasing barometric pressure indicates storm, rain and windy weather. Rising barometric pressure indicates fair, dry and colder weather. Slow, regular and moderate fall in pressure suggests a low pressure area is passing some distance away, marked by changes in weather are unlikely. Small, rapid decrease in pressure indicates a nearby change in weather. A quick drop in pressure over a short time period indicates a storm is likely to be in 5 to 6 hours, which is the condition our pressure sensor was demonstrating right now. And last but not the least, a large, slow and sustained decreasing pressure forecasts a long period of poor weather. This was a complete description of the design and the dedicated system which we have built. In the end, we would like to acknowledge Texas Instruments India for providing us the platform so that we can turn our dream project into reality. We would like to thank Dr. Prashan Ghoshal, whose constant mentoring helped us to rectify our wrong steps. Further, we would also like to thank the Information Technology and Electronics and Telecommunication Department of our college, which provided us with all possible help. Last but not the least, sincere thanks to Mr. Sagar Juneja for providing us concerned information from time to time. Thank you.